Hi, welcome back, or if this is your first time here, welcome to the Q&A channel. I'm your host, Professor Qanda. In today's episode, I'm going to answer an interesting question. What is quantum computing? So sit back and enjoy the video, and remember to hit those like and subscribe buttons. Let's get started. What if a computer could solve problems in minutes that would take today's most powerful supercomputers thousands or even millions of years? What if the future of computing wasn't based on billions of tiny switches turning on and off, but instead harnessed the strange and mysterious laws of quantum physics? It sounds like science fiction, but it's real, and it's called quantum computing. Today, I'm exploring a technology that could fundamentally change everything from medicine and artificial intelligence to cybersecurity and materials science. For over 70 years, computers have operated using a simple concept, the bit. A bit can exist in one of two states, 0 or 1. Every website, smartphone app, video game, an artificial intelligence system is built from billions of these tiny digital decisions. But as computers become more powerful, we're approaching physical limits. Transistors can only become so small. Processing power can only increase so much. That's where quantum computing enters the picture. Instead of using traditional bits, quantum computers use something called a qubit. And qubits follow completely different rules written by quantum physics. To understand quantum computing, we need to talk about one of the strangest ideas in science, superposition. A traditional bit is either a 0 or a 1. A qubit can exist as both at the same time. Imagine flipping a coin. A normal computer sees either heads or tails. A quantum computer can work with the coin while it's still spinning in the air. This allows quantum computers to process many possibilities simultaneously. Then there's another strange phenomenon called entanglement. Einstein famously called it spooky action at a distance. When two qubits become entangled, they remain connected regardless of the distance separating them. A change in one instantly affects the other. This connection allows quantum computers to coordinate calculations in ways impossible for traditional machines. Together, superposition and entanglement create enormous computational potential. Quantum computers won't replace your laptop. They aren't designed for browsing the internet, checking email, or playing games. Instead, they excel at solving specific types of incredibly difficult problems. For example, discovering new medicines. Creating a new drug often requires simulating molecular interactions involving billions of variables. Traditional computers struggle with this complexity. Quantum computers could model these interactions much more accurately, potentially accelerating medical breakthroughs. Materials science is another major opportunity. Scientists could design stronger batteries, more efficient solar panels, and entirely new materials by simulating atomic behavior directly. Artificial intelligence may also benefit. Future quantum systems could process massive optimization problems far faster than conventional computers. And perhaps most famously, quantum computing could revolutionize cryptography. Many of today's encryption methods depend on mathematical problems that are difficult for classical computers to solve. A sufficiently powerful quantum computer could solve some of those problems dramatically faster. That's why governments and cybersecurity experts worldwide are already preparing for the quantum era. Despite the excitement, quantum computing remains one of the most difficult engineering challenges ever attempted. Qubits are incredibly fragile. Tiny vibrations, temperature changes, electromagnetic interference, even cosmic rays. Any of these can disrupt a quantum calculation. To overcome this, many quantum computers operate at temperatures colder than outer space, just fractions of a degree above absolute zero. Engineers must also deal with quantum errors. Unlike traditional computers, quantum systems are highly sensitive and prone to mistakes. Building reliable, large-scale quantum computers requires sophisticated error correction techniques and enormous technical precision. In short, creating a useful quantum computer is extraordinarily difficult, but progress is happening faster every year. Around the world, governments, universities, and technology companies are investing billions of dollars into quantum research. Major players include companies like IBM, Google, Microsoft, and numerous startups racing to develop practical quantum systems. Researchers are exploring multiple approaches, including superconducting circuits, trapped ions, photonic systems, and other exotic technologies. No one knows exactly which approach will ultimately dominate, but the competition is driving rapid innovation. Many experts compare today's quantum industry to the early days of classical computing in the 1950 seconds and 1960 seconds. The technology is still young, but the potential is enormous. Quantum computing isn't simply a faster computer. It's an entirely new way of processing information. By harnessing the bizarre principles of quantum mechanics, these machines could tackle problems that are currently beyond humanity's reach. New medicines, advanced materials, breakthrough energy technologies, powerful artificial intelligence, and solutions to scientific challenges we haven't even imagined yet. The road ahead remains difficult, but if quantum computing fulfills even part of its promise, it could become one of the most important technologies ever created. The computer revolution transformed the world. The quantum revolution may transform it again. The next great breakthrough may not come from thinking bigger. It may come from thinking quantum. I hope you enjoyed the answer to the question, what is quantum computing? Before you move on to the next video, and if you haven't done so already, hit those like and subscribe buttons. It really helps out the channel. This is Professor Qanda saying thanks for watching and bye for now. See you in the next Q&A channel video.